effect of inert gas addition. We have discussed about effect of inert gas in addition. We have seen that if we add the inert gas at constant volume, the addition of inert gas does not create any effect. But if the inert gas like argon is being added, if inert gas is added in the system in equilibrium at constant pressure, what happens? It generates the effect as if we have decreased the pressure, and ultimately it affects as if it is so when an inert gas is added to the system in equilibrium at constant pressure, total volume is allowed to change or volume is changed. As such, after addition of gas, pressure remains constant. To maintain same pressure, my dear students, volume has to be increased. And when volume increases, we get the effect like pressure increases. So the total volume will increase, hence the number of moles per unit volume of various reactants and products decreases. And hence, when delta N gas is greater than 0, number of gaseous moles of products is greater than the number of gaseous moles of reactants, and thus the forward reaction takes place. And when delta N gas is less than 0, my dear students, we know that number of products or number of gaseous moles of products is less than the number of gaseous moles of reactants, and ultimately the reverse reaction takes place. So the equilibrium shift in the direction where the number of moles of gas increases, my dear students. If the inert gas is added and volume is decreased, pressure is increased, and we will get the effect as if we have increased the pressure. So this was a wonderful example by which we can understand the effect of addition of the inert gases. Now whatever we have studied, let us revise it, let us understand it, let us drill it with some of the examples so that we can understand it better. Let's look at the first question. Does the number of moles of reaction product increase or decrease, decrease or remain same when each of the following equilibrium is subjected to decrease in pressure by increasing the volume? So what is the rule? Let us first look at. When delta N gas is equal to 0, there is no effect of pressure. If delta N gas is greater than 0, then we have Np is greater than Nr, and thus when we decrease the pressure, forward reaction takes place. When delta N gas is less than 0, we have Np is less than Nr, and that is why the decrease in pressure will cause the reverse reaction to take place. So this is how, my dear students, we understand the effect for these particular cases. Now let's, following this rule, let us solve the problem. But once again, please remember, when delta N gas is greater than 0, decrease in pressure will cause forward reaction. When delta N gas is less than 0, decrease in pressure will cause the reverse reactions. Now here, if you look at PCl5, that gives PCl3 plus Cl2, my dear students. You can see that Np, number of product, is equal to 1 plus 1, that is 2. This is 1 mole, this is 1 mole. So both are gaseous mole, so total 2 mole of gaseous products, and in case of reactants we have only 1 mole of gaseous products. Therefore delta N gas is equal to Np minus Nr, that is 2 minus 1, and that is 1, which is greater than 0. So decrease in pressure will cause the forward reactions, and the number of mole of reactant products will increase. Next question, my dear students, we have a reaction CaO solid plus CO2, that gives CaCO3. If you look into the product side, there is no gaseous mole because it is the solid, and only reactant side we have 1 mole of gas, that is 1 mole of CO2. Calcium oxide is also solid, and therefore delta N gas is equal to NP minus NR. Product side there is no gaseous moles. Reactant side there is only one, so it is -1, which is less than 0, and thus decrease in pressure will cause the sorry, reverse reaction to proceed, and thus the number of moles of reactant products will decrease. Now we look to the third equation. In third equation, you can see that 3Fe solid plus 4H2O gas. It gives Fe3O4 solid and 4H2 gas. So here you can see that we have a reactant side 4 moles of gas, product sides even we have 4 moles of gas. So both the side, the NP and NR are equal. So NP is equal to 4 and NR is equal to 4, and therefore delta N gas is equal to 0. And when delta N gas is equal to 0, my dear students, there is no effect of, there is not at all any effect of pressure in this case when we have delta N gas is equal to 0. Let's move and understand the next. Which of the following reaction will be affected by increase of pressure? Predict the forward or backward reaction too. So we need to understand the backward and forward reaction. Let us understand the rule. Whatever we have studied, it is the conclusion of that. That if we have delta N gas is equal to 0, there is no effect of pressure. If we have delta N gas is greater than 0 and NP is greater than NR, and therefore increase in pressure will cause the reverse reactions. And if we have delta N gas is less than 0, so we know that we have NP is less than NR, and increase in pressure will cause the forward reactions. It's a simple rule. So now we'll decide that if delta N gas is greater than 0, increase in pressure will cause reverse reactions. If delta N gas is less than 0, increase in pressure will cause the forward reactions. Let us understand it. COCl2 that gives CO gas and Cl2 gas. So product side we have 1 mole of gas, 1 mole of gas, total 2 mole of gas, and in reactant side we have only 1 mole of gas. So NP minus NR is equal to 2 minus 1, which is 1, that is greater than 0, and therefore the reverse reaction takes place because in all cases we are going to increase the pressure. So increase in pressure will cause the reverse reaction. Next question, CH4 gas plus 2H2 gas, that gives CH2 gas plus 2H2S gas. If you look into the product side, my dear students, we have total number of moles is equal to 2 plus 1, 3. If you look into the reactant side, you have total number of moles 2 plus 1, 3. So delta N gas is equal to 0, and therefore no effect of either increasing or decreasing the pressure. When you look at the third equation, you will find that we have a CO2 gas plus CS solid, that gives 2 CO gas. So product side we have 2 mole of gases, and reactant side we have only 1 mole of gas. Carbon is solid. So we can write delta N gas is equal to NP minus NR. The number of gaseous moles in product is 2, number of gaseous moles in reactant is 1, and that is what it is 1, which is greater than 0. So increase in pressure, delta N gas is greater than 1, actually greater than 0, not 1, is greater than 0, and therefore increase in pressure will cause reverse reaction to take place. Then next question, my dear students, 2H2 gas plus CO gas, that gives CH3CO gas. On the product side, if you look at, we will have 1 mole of gas. On the reactant side, we have 1 mole plus 2 mole, that is 3 mole of gas. And therefore, NP minus NR, that is the number of gaseous moles of products minus number of gaseous moles of reactants, is equal to 1 minus 3, that is minus 2, which is less than 0, and therefore increase in pressure will cause the forward reaction to take place. Same way, if you look into the next question, CaCO3 solid, that gives CO solid plus CO2 gas. We have only 1 mole of product, gaseous mole, all the two, one product and one reactant, both are solid. So here, delta N gas is equal to NP minus NR, which is 1 minus 0, that is equal to 1, which is greater than 0, and therefore delta N gas is greater than 0, and therefore increase in pressure will cause the reverse reaction to take place. We have next question. 4NH3 gas plus 5H2O gas, that gives 4NO gas plus 6H2 gas. You can see that we have product side 6 plus 4, total 10 mole of gaseous molecules. And if you look into the reactant side, we have 4 plus 5, 9 mole of gaseous molecule. So delta N gas is equal to Np minus Nr. Product side 4 plus 6, reactant side 4 plus 5. So 10 minus 9, which is 1, that is greater than 0. So delta N gas is greater than 0, and therefore increase in pressure will cause the reverse reaction to take place. प्यारे बच्चों, अगर आप देखेंगे तो आई हैव बीन सॉल्विंग ऑल द क्वेश्चंस फ्रॉम द एक्सरसाइज. तो इस चैप्टर में भी हम एक्सरसाइज के ऑलमोस्ट बहुत सारे क्वेश्चन सॉल्व कर रहे हैं. लेट्स लुक एट द नेक्स्ट क्वेश्चन. Dihydrogen gas is obtained from the natural gas as CH4 gas plus H2O gas, that gives CO gas plus 3H2 gas. So if you look into the product side, you have 3 plus 1, 4, so if you look at the product side, you can see that we have 4 moles of gaseous molecules, and on the reactant side we have 1 plus 1, that is 2 moles of gaseous molecules. Now what do we need to do? By oxidation with the steam, write the expression for Kp. So we know that for Kp we write the partial pressure of products to the power raised to their equal to their equilibrium coefficient. So the partial pressure of carbon monoxide into the multiplied by the partial pressure of hydrogen gas to the power 3 divided by the partial pressure of methane multiplied by the partial pressure of water. Now the next question. What will be the value of Kp composition of mixture be affected by increasing the pressure? So if we increase the pressure, my dear students, first we need to find out delta N gas. Here delta N gas is equal to Np minus Nr. Np is equal to 1 plus 3 and Nr is equal to 1 plus 1, that is 4 minus 2, which is 2. Here delta N gas is greater than 0, therefore Np is greater than Nr. So increase in pressure will decrease the number of moles of gases, and therefore backward or reverse reaction takes place if you increase the pressure. Value of Kp decreases because when the reverse reaction takes place, value of Kp decreases. So please remember that when we increase the pressure, reverse reaction takes place, and as the reverse reaction takes place, the value of Kp decreases. Concentration of reactants or partial pressure of reactants would be increased. So as the reverse reaction takes place, concentration of reactants will increase or the partial pressure of reactant will increase. Now we want to understand the increasing effect of temperature. So as this is an oxidation with steam, my dear students, oxidations are exothermic in nature or steam is utilized, so favoring the temperature, and therefore increasing temperature will increase the value of Kp. So when we will increase the temperature, my dear students, the value of Kp will be increased. We are already aware that these equilibrium constants are temperature dependent and their value generally increases when the temperature increases. So increasing temperature to a limited value will increase the concentration of product. After some level of increase, carbon monoxide, water, that gives carbon dioxide and hydrogen, maybe CO2 will be added to the composition of mixtures. So after some time, if the reaction takes place, this CO, actually we have been, if you look into the question, question once again, we will realize that here the reaction, whatever it takes place, just a minute. Just look at this, that methane is converted to carbon monoxide gas. But this is what it happens to lower temperature. Now if we keep on increasing, what happens? This carbon monoxide, which is produced, again reacts with the steam. So when this carbon monoxide, you can see here, when carbon monoxide react with the steam, we get carbon dioxide. So after certain level, if we increase the pressure, after some level of increase in pressure, CO or carbon monoxide will react with steam and produce carbon dioxide gas, and maybe CO2 gas will be added to the reaction mixture. So up to certain level of increase in temperature, the value of Kp increases and the reaction move forward into the forward direction. But after some temperature, carbon monoxide again reacts with water and produce carbon dioxide, and thus the carbon dioxide may be added to the reaction mixture. Now, my dear students, we have the next idea, that is using the catalyst. So, my dear students, using the catalyst will not change the value of Kp, only time to acquire or time to attain the equilibrium will be increased. So please remember that when we use the catalyst, my dear students, catalyst does not affect the equilibrium constant, but catalyst only increases the rate of the forward reaction and increases the rate of the reverse reactions, and thus we can reach the equilibrium faster, but there is no effect of catalyst on the equilibrium constant. Once again, catalyst only increases the rate of forward and reverse reaction, that also equally, and thus the equilibrium can be obtained faster, or the time required to increase, or the time required to obtain the equilibrium, that time has been decreased by using the catalyst. Now, my dear students, we have one more question to solve. On the equilibrium of the reaction 2H2 plus CO gas that gives CH3OH gas, decrease the effect of addition of hydrogen. Describe the effect of addition of hydrogen. So, we need to describe the effect of addition of hydrogen. Let us look at that. What happens if we add hydrogen? So, you can see here hydrogen is a reactant. And at equilibrium, if we add the reactants, the reaction move into the forward direction, and we get more products. So on addition of hydrogen, reactants equilibrium, on addition of hydrogen, which is reactant, equilibrium will shift towards the product side and forward reaction takes place. Now suppose we add addition of methanol. So we know that methanol is a product. So on addition of product, that is methanol, equilibrium will shift toward the reactant side and reverse reaction takes place. Now we want to remove removal of CO. We know that CO is a product. In this reaction, carbon monoxide is a product. So when we remove the CO, that means we decrease the concentration of reactants. And when we decrease the concentration of reactants, the reverse reaction takes place, or the backward reaction takes place, and equilibrium shift towards the reactants. So this is what it happens, that the equilibrium moves shift towards the reactants. Then we have the next one, which is the removal of methanol. So when methanol is being removed, which is a product, so product concentration is decreased, the forward reaction takes place, and we get more methanol to be produced. So equilibrium will shift towards the products and the forward reaction takes place. The previous question was completely based on the idea of change or idea of effect of changing concentration at equilibrium. Now let's look at the next question. At 473 Kelvin temperature, equilibrium constant Kc for the decomposition of phosphorus pentachloride PCl5 is 8.3 into 10 to the power minus 3. If decomposition of PCl5 is depicted as, it is written as PCl5 that gives PCl3 plus Cl2 gas, the delta or the enthalpy of reaction is equal to 120.4 kilojoule per mole. Now what do we need to do? Write the expression for Kc. So we can write Kc is equal to concentration of products multiplied by the divided by the concentration of reactants. So product we have PCl3 and Cl2. So concentration of PCl3 multiplied by the concentration of Cl2 divided by concentration of PCl5. So ultimately we get 8.3 into 10 to the power minus 3. Next one is, what is the value of Kc for the reverse reactions? So what if we do the reverse reactions? We know that when we have a reverse reaction, the value of equilibrium constant become inverse. So for reverse reaction, if equilibrium constant is Kc dash, then Kc dash is equal to 1 upon Kc. So you can see here 1 upon 8.3 divided by 10 to the power minus 3. So by doing the required calculation, my dear students, we get the answer for Kc dash is equal to 1.2 into 10 to the power 2. Now next question, my dear students, what will be the effect of what will be the effect on Kc if more PCl5 is added? You are well aware that PCl5 is a reactance, and that if more PCl5 is added, the forward reaction takes place and value of Kc increases. Let's go and understand the next one. If pressure is increased, what happens if pressure is increased? Here delta N gas is equal to Np minus Nr. When you look at the number of gases, moles of products, we have PCl3 gas and we have Cl2 gas. So there are 2 moles of a number of products, and we have only PCl5 gas as a reactant. So 1 mole of gaseous reactants, therefore 2 minus 1, which is equal to 1. Now delta N gas is greater than 0, so Np is greater than Nr, and increase in pressure will cause the reaction go towards the least number of moles, and thus the reverse reaction takes place. So please remember, and if the reverse reaction takes place, the value of Kc decreases. Now the next question, temperature increases. What happens if the temperature increases? Here if you look into the question, you will come to know that delta H is given, and delta H is 124 kilojoule per mole. That represents the endothermic reactions. So therefore increase in temperature will be favored. So when we increase the temperature, the forward reaction takes place and value of Kc is increased, and thus the forward reaction takes place. So my dear students, it is very much important for you to understand and apply the knowledge of all that factors affecting equilibrium. So this is how we have discussed so many questions. Let's look at the one more question. What happens if an inert gas is added to the container, increasing the total pressure at constant temperature and constant volume? Now see, here we have used constant temperature, means we would not allow the temperature to increase, and we will not allow the volume to be increased, but just we allow the increase in pressure. We have studied, my dear students, that if the inert gas is added at constant volume, there will be no effect of adding the inert gas. So in this case, total pressure will stay constant. Even the partial pressure of molar constant or molar concentration will also remain constant. Thus, if inert gas is added at constant volume, it does not create any effect. Now, my dear students, we want to study about the effect of catalyst. Though in one of the question I have explained it, let us once again understand it well. A catalyst alters the pathway of the reactions and chose the path with low activation energy. Please remember that the catalyst alters the pathway of the reaction and choose the pathway which is having the low activation energy, but increase the rate of forward reaction and reverse reaction equally. Please remember that it increased the rate of forward reaction, it also increased the rate of reverse reaction, but the increase in both forward and reverse reaction is equal, and equilibrium is obtained or established faster. So when we utilize catalyst, the time required to attain the equilibrium has been decreased and the equilibrium is established faster. Otherwise, state of equilibrium is not affected by the catalyst. So catalyst does not affect the state of equilibrium. Please remember and understand it well, my dear students. So if value of K is extremely small, catalyst would be of little help. This is also an important point, that if you have the value of K, that is the equilibrium constant, is very small, my dear students, this small value of K, if we have the very small value of K, then even using the catalyst will make not much difference to the chemical reactions, and the catalyst will be of very little help, or even the using of catalyst will not be helpful in that case where we have the value of equilibrium constant is very small. Now, my dear students, we want to understand some more things, and we should understand about the equilibrium constant, or about the equilibrium in ionic solution, ionic equilibrium in solutions. So let's move forward and understand it, my dear students. Equilibrium involving ions in aqueous solution, which is called the ionic equilibrium. So if at equilibrium ions are involved, that equilibrium is considered as an ionic equilibrium. Aqueous solution of sugar does not conduct electricity. Please remember that if we take sugar and add it into the water, and then if we pass electricity, thus such solution does not conduct electricity. But aqueous solution of NaCl conduct electricity. Thus, some substances their aqueous solution conduct electricity, some substances their aqueous solution does not conduct electricity. Conductance of electricity increase with increase in concentration of salt in water. NaCl solution not only conduct the electricity, but if you increase the concentration of NaCl into the solution, the uh, uh, the conductivity or the conductance of electricity also increases in case of NaCl. So there was a scientist, his name was Michael Faraday. Michael Faraday classified the substances into two various categories based on their ability to conduct electricity. The first class, he said, that was known as the electrolyte. What is an electrolyte? Electrolyte is a substance that conduct electricity in their aqueous solutions, and they are called electrolytes. So what are the non-electrolytes? Non-electrolytes are the substances that do not conduct electricity in their aqueous solution. So such substances are known as non-electrolytes. Now, my dear students, if we study about the electrolytes which conduct the electricity in their aqueous solution, these electrolytes can be of two types. One is strong electrolyte, another is weak electrolyte. What is the meaning of strong electrolyte? So, when these strong electrolytes are dissolved in water, on dissolution in water, these strong electrolytes are ionized almost completely. For example, NaCl. NaCl undergoes almost 100% ionization. Same way, my dear students, when we look into the weak electrolytes, when weak electrolytes are added to the water or on dissolution in water, these weak electrolytes ionized or dissociated partially. They do not dissociate or ionize completely, but they are dissociated partially or in a very small percentage. For example, if you take the CH3COOH, acetic acid, when it is added to water, it ionizes less than 5%. So, my dear students, this is how we understand about the electrolytes and non-electrolytes. Let us study more about them. In case of weak electrolyte, equilibrium is established between ions and the unionized molecules. Please remember that when there is an ionic equilibrium for the weak electrolyte, see, I'm talking about weak electrolyte. In case of weak electrolyte, when we have an equilibrium established between the weak electrolyte, then there will be an equilibrium between the ions present into the solution and the unionized or solid molecules. So let us understand this by this. Suppose we have added one salt and this salt is weak electrolyte. This salt is weak electrolyte, or this substance, not salt, let's say it's substance. So this substance is weak electrolyte. Now what happens, being weak electrolyte, it produces some of the ions, positive ion and negative ion. This positive ion and negative ion, and we will also have some unionized molecules remain present into the solutions. And there will be an equilibrium between these ions and the uh, unionized or undissociated salt. So there will be an equilibrium between the solid substance, and that equilibrium is established with the positive ion, and or you can say that cation and anion. So there will be an equilibrium between the cation plus anion and our solid substance. So please remember that when we have weak electrolyte, there will be an equilibrium established between the undissociated salt or undissociated substance and the ions that are produced by the dissociation or ionization of that substance. Acid, base and salts come under the category of electrolytes. So acids, base and salts are actually the electrolytes, and they may act as either strong electrolyte or weak electrolyte. And that is what we have studied in 10th standard also, that we may have strong acid and strong base, strong weak acid and weak base, and we can even have the various types of salts like acidic salt, basic salt and neutral salt. So my dear students, इफ यू कुड नॉट अंडरस्टैंड एनीथिंग, बच्चों अगर आपको ये पूरी डिस्कशन में कुछ समझ में नहीं आया तो आप लोग मुझसे पूछ सकते हैं। बच्चों क्या आप मुझे सुन पा रहे हैं?
यस सर।
अगर बच्चों
Yes, sir.
अगर आपको कुछ समझ में नहीं आया तो आप मुझसे पूछ सकते हैं, या
हाँ
प्लीज
सर।
बता दीजिए अगर सब कुछ समझ में आया है तो। कुछ पूछना है बच्चों आपको?
नो सर।
No, sir.
Okay, then let us stop the class and do the required revision.